Hello Legacy Sabers, Marsh here. So today we're going to graph logarithms. You're going to want your notes, some graph paper, two in fact, and then your thinking caps today as well. So let's think here. How can I graph f of x equals log base 3 of x? Well, ultimately f of x is just a y, right? So I can rewrite so that this is a y. So y equals log base 3 of x. Well, we know that we can convert that, right? So I can convert that to 3 to the y equals x. Now what I can do is plug some numbers in for y, right? So what if I plug in a -1, but I'm plugging in for y, aren't I? Not x. I'm so used to plugging in there. There we go. There you go. I'll plug -1 in there, plug a 0 in there, plug a 1 in there, a 2 in there, that kind of thing. Well, if I go 3 to the -1, well, that's 1/3, right? 3 to the 0, that would be 1. 3 to the first is 3. 3 squared is 9. So notice, guys, if I graph this, I'll get 1/3 -1. 1 0 3 1 and 9 2. It's going to be a graph that's going to look something like this, which we saw when we did our activity today on the rumor activity. Created a graph that looks very similar to this. Now notice, guys, what did I do? Ultimately, I just converted to exponential form, but you're not going to want to do that every single time. It's going to take forever. So what we're going to do is look at our table here and look at the x values I plugged in. Notice this was the base, 1 over the base, right? And this was 1, which was the base to the 0 power. This was base to the first power, and this was base squared, right? Ultimately, that's what we did. So ultimately, when we're graphing a log, some stuff to know. Your parent table is only going to need to contain 2 points. If you want to contain a little couple more, that's up to you. But your parent table is only going to need to contain 1 0 and whatever the base is, comma 1. You could also include, if you want another point on there so you get a nice graph, that would be base squared, comma 2. If you want to do that one as well. So if I was graphing f of x equals log base 5 of x, I would graph the points 1 0 and 5 comma 1. Because if I have log base 5 of 5, that's a value of 1. These graphs are going to have asymptotes. They're going to be vertical. We just saw that on the last one. And transformations are still going to be used definitely in all of these graphs. So let's take a look at a graph. I got f of x equals log base 3 of x minus 4. So same thing I'm going to do. I'm going to write out myself a table here. And I'm going to only use I'm going to use 2 points. So I said 1 comma 0 and the base comma 1, right? Yeah, 1 comma 0, base comma 1. So I got my parent table here. Now I gotta think. Well, there's no stretches, right? There's no number multiplied here. There's nobody in the outside over here, so that means I'm not adding or I'm not going up or down. I am, however, going right 4, right? So I'm going to add 4 to all the sides here on the x. I can figure out my table. So that'd be 5 comma 0 and 7 comma 1. So let's graph that. 5 comma 0, 7 comma 1. And this graph's going to do something like that. Now notice, guys, notice how I did not draw on x equals 4. Because just like when we were graphing exponentials and the vertical shift dictated where your asymptote was, Well, normally your asymptote's at x equals 0, so the y-axis. But if I move left or right or up or left or right, that's going to cause my asymptote to also move. So in this case, my asymptote will be located at x equals 4 on this graph. My domain, negative infinity to infinity. And my range, oh no, hold on. That's not my domain. Silly, silly Marsh. That is not my domain. I have a problem in my domain, don't I? Can't get my pen to work today. There we go. So, it looks like it starts at 4, right? And then we're going to infinity. But my range, I do get all the positive y's and all the negative y's. So my range is negative infinity to infinity. So basically like the inverse of an exponential, right? Because domain was negative infinity and to infinity on an exponential, and the range was what was confusing, had a limitation. Notice, guys, I can't plug in like 0 into this log because I'd get -4, and that would cause you to get non-real answer. That's why when we're solving with logarithms, we had to be careful on what we substituted in for an x so we would not get not real answers. Let's try a really, really big one. So, same thing, I'm going to start with my table of my 2 points, 1, 0, and then base comma 1, so that'd be 2 comma 1, because the base of my log is 2. Now I gotta do some moving. So it looks like I gotta stretch by 2. So I'm gonna do that. Stretch by 2. I gotta go right 2. So I'm gonna go right 2. And I'm gonna go up 5. So up 5. Okay, let's figure out where my new table is. So I got 3 and 4 for the x's because I added 2. 0 times 2 is 0 plus 5, 5. 1 times 2 is 2 plus 5, 7. So I got those 2 dots to put on my graph. 3 comma 5, 4 comma 7. And then since I went right 2, right, my asymptote will be located right here. So my graph's going to do one of these jobs. Whee! Something like that. So my domain would be from 2 to infinity. Notice there's no bracket on 2 because I can't touch the asymptote. Okay, can't cross it, so I can't have a bracket on it. Range, however, I am getting all of the y's. And my asymptote is located at x equals 2. And that's the end of this video. See you later, Sabers.